Hello, my dear children. How are you? Now, come to the new class, number systems. In this class, we are going to discuss about number systems. See here, introduction. In your earlier classes, you have learnt about the number line and how to represent various types of numbers on it. Isn't it, my dear children? Now see this number line. On this number line, we mark the points at equal distances and we label the points like 0, 1, 2, 3, 4. Left side of the 0 minus 1, minus 2, minus 3 and so on. This is called number line. Okay, my dear children. Now come to the different types of numbers. First numbers. Numbers like 1, 2, 3, 4, 5 and so on. These are numbers are called natural numbers. Okay, my children, you have already learned. Just we are recalling that previous knowledge. Okay, my children, the collection of natural numbers is denoted by the symbol capital letter N. Therefore, capital letter N is equal to 1, 2, 3, 4, 5 and so on. Okay, my children, you have learned this point earlier class in your earlier class. Now come to the second system of numbers. Numbers like 0, 1, 2, 3, 4, 5 and so on are called whole numbers. The collection of whole numbers is denoted by the symbol W. Okay, my children. Therefore, W is equal to 0, 1, 2, 3, 4, 5, and so on. Okay, my children, this is second kind of number system. Now, next kind of number system. The numbers like and so on -4, -3, -2, -1, 0, 1, 2, 3, and so on. These numbers are called integers. The collection of all integers is denoted by capital letter Z. Here the letter Z comes from the German word Zahlen, which means count. Okay, my children, right. Therefore, Z is equal to and so on -4, -3, -2, -1, 0, 1, 2, 3, and so on. Okay, my children, right. Now, the next kind of numbers. The numbers like 1, 2, 3, 4, 5, and so on are called positive integers. These are also nothing but natural numbers. So, natural numbers are also said to be positive integers. The collection of positive integers is denoted by the letter Z plus, not Z to the power of plus, Z plus. Therefore, Z plus is equal to 1, 2, 3, 4, 5, and so on. Understood, my children? The set of natural numbers, the collection of natural numbers is nothing but the set of positive integers. Both denote the same. Okay, my children, in a higher classes, in general, we use this word only. We don't use natural numbers, positive integers. Positive integers means immediately you have to recollect, you have to remember these numbers only 1, 2, 3, 4, 5, and so on. Okay, my children, right. Now come to the next number system. The numbers like -1, -2, -3, -4, -5, and so on are called negative integers. These numbers are called negative integers. The collection of negative integers is denoted by the symbol Z minus, not Z to the power of minus. We read it as Z minus. Z minus is equal to -1, -2, -3, -4, -5, and so on. Is it clear, my dear children? What is meant by negative integers? What are negative integers? Right. Now come to the next system of numbers, that is sixth part. The numbers like 0, 1, 2, 3, and so on are called non-negative integers. Okay, my dear children, these are called non-negative integers. These are also nothing but whole numbers. Whole numbers and non-negative integers denote the same. In higher classes, we use this word only, non-negative integers, not whole numbers. Understood, my dear children? Right. Now come to the next number system. Numbers like 1 by 2, 3 by 4, or even minus 2005 by 2006, and so on are called rational numbers. You know, these are all fractions. Okay, my children. But here the numbers, these are called rational numbers. The collection of rational numbers is denoted by the letter Q, capital letter Q. Rational comes from the word ratio. This word rational is derived from the word ratio, and the capital letter Q comes from the word quotient. So here the first letter of this word quotient is Q. So we use here capital letter Q to denote the collection of rational numbers. Understood, my dear children? The number R is called rational number if it can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. If any number R, if it is written in the form of P by Q, where P and Q in the numerator integer and the denominator also integers, both should be integers, and q should not be equal to 0. Denominator should not be 0. Understood, my dear children? Right. Notice that all the numbers which can be written in the form p by q, where p and q are integers and q is not equal to 0. For example, minus 25 can be written as minus 25 by 1. Here p is equal to minus 25 means numerator is equal to minus 25 and q is equal to 1, and means that denominator is equal to 1. Therefore, the rational numbers also include the natural numbers. It is nothing but positive integer. Whole numbers, they are also nothing but non-negative integers and integers. Okay, my dear children? Right. Now come to the next point, eighth point. The rational numbers do not have a unique representation in the form p by q, where p and q are integers and q is not equal to 0. So, a rational number cannot be represented uniquely. Let us see example. For example, 1 by 2 is equal to 2 by 4, that is equal to 10 by 20, that is equal to 20 by 50, that is equal to 47 by 94. If you simplify all these fractions, if you simplify all these rational numbers, we get 1 by 2 only, and so on. Isn't it or not, my dear children? Right. Therefore, this 1 by 2 is represented in different ways, 1, 2 by 4, like 10 by 20 or 20 by 50 or 47 by 94 and so on. Understood, my children? Right. These are all called equivalent rational numbers or fractions. Understood, my children? A rational number p by q is said to be in its simplest form if p and q have no common factors other than 1. So, if any rational number is given, then the rational number is said to be in its simplest form. If the numerator and denominator have the common factor only 1, It does not have any other common factor other than 1. That is, P and Q are co-primes. Understood, my dear children? Recollect the definition of co-primes. Okay, my dear children. So on the number line, among infinitely many fractions equivalent to 1 by 2, we will choose 1 by 2 to represent all of them. Okay, my children, in the example, there are so many equivalent fractions which are equal to 1 by 2. So this is the simplest form of all that rational numbers. So we choose this number only to represent a number on the number line. Understood, my children? Right. Now remark. See, remember this point. There are infinitely many rational numbers between any two given rational numbers. Between any two rational numbers, there are infinitely many rational numbers will be there. Understood, my children? Right.